The Zoom session is being brought to you by the Fractal Snow Point. Right, for today, we begin chapter 6, which is going to be about linear systems. Double check that. Linear systems, and right now, solving linear systems by matrices. So, a matrix, it's an array of numbers, a rectangular array of numbers, R rows, K columns, that's the usual notation. And yeah, matrices and determinants, matrices, algebra, matrices, inverse matrices, and determinants. For now, matrix row operations. This one is a 2 rows, 3 columns, so it's a 2 by 3 matrix. For every linear system, you can write its augmented matrix. You have this 2 by 2 system, 1 by x plus 2y equals 6, 3x minus y equals -10. So you put these numbers 1, 2, 6 here, 3, -1, -10 here, and get a 2 by 3 augmented matrix. Augmented by this last column corresponds to the constants that the values equal. Whereas 1, 2, 3, -1, we will later see called the coefficient matrix, which we'll take inverses of, basically the equivalent of dividing. So we'll solve these by doing row operations on the augmented matrices. Sort of like how we did with solution by elimination, only we skip a lot of writing out x's and y's and equal signs. So for example, 2x minus y equals -1, x minus 2y equals 1. We translate to an augmented matrix. 2, -1, -1 here, first row. 1, -2, 1 here in the second row. Now I'll do the same row operations to pivot on column on special entries and try and reduce it to 1, 0 constant, 0, 1 constant, these being the values of x and y. So we'll start off by pivoting on this entry, i.e. clear its column. Well, here we have a 2, so you have to take twice of row 2 from row 1. So for example, 2 minus twice 1 is 0. There it goes. -1 minus twice -2 is 3, which goes here. -1 minus twice 1 is -3, which goes here. So after all that, we get 0, 3, 3. Put 1, -2, 1 here. Okay. Now this row we'll adjust by dividing throughout by 3, because it corresponds to the equation 3y equals -3. So we divide by 3 and get 0, 1, -1. All right, we have an equation for y. Y equals -1. Now I'll pivot on this entry, this one here. I eliminate this -2 in here, and we'll do that by adding twice of row 1 to row 2. 1 plus twice 0 is 1, so a 1 goes there. -2 plus twice 1 is a 0, so a 0 goes there. 1 plus twice -1 is a -1, so a -1 goes there. Now we have this matrix, 0, 1, -1, 1, 0, 1, 0, -1. We'll swap rows so we get a diagonal matrix, 1, 0, 0, 1. X plus 0y equals -1. 0x plus y equals -1. So x equals -1, y equals -1. We have a solution. That's the solution. X is -1, y equals -1. Solve this original system. So we use row operations to get a matrix of the form 10A, 01B. That translates back to x equals A, y equals B. Here's another one. X plus y equals 2, x minus y equals 6. So 1, 1, 2 for the first row. 1, -1, 0. That's a 0, not a 6. I'm sorry. For the second row. 0, 1, 1, 1, 1, 1, 2, 1, -1, 0. I'll pivot on this one here, i.e. clear its column. So to do that, we'll eliminate this one here, and we'll do that by subtracting row 1 from row 2. 1 minus 1 is a 0, 0 goes there. -1 minus 1 is a -2, -2 goes there. 0 minus 2 is a -2, -2 goes there. 1, 1, 2, 0, -2, -2. This row will rescale by dividing by -2. Get 0, 1, 1, 1, 2, 0, 1, 1. Good. The second row corresponds to the equation y equals 1, so we're already in a position we're getting close to a solution. I pivot on this one to eliminate this one here. We'll do that by subtracting row 2 from row 1. 1 minus 0 is 1, a 1 goes there. 1 minus 1 is 0, a 0 goes there. 2 minus 1 is 1, a 1 goes there. Here we have it, 101, 011. this translating back to a system, this is 1x equals 1, 1y equals 1, x equals 1, and y equals 1. Here we have a 2 by 2 system. X minus 3y is 9, minus 2x plus 6y is 18. So 1, negative 3, 9, first row. Negative 2, 6, 18, second row. All right, this second row has a common factor of 2, or negative 2 divided by that. And we get 1, negative 3, negative 9. Uh-oh. Same 2 rows, identical rows. This is not going to work out well. I'll pivot on this one by subtracting row 1 from row 2. 1 minus 1 is a 0 goes there. Negative 3 minus negative 3 is a 0 goes there. Negative 9 minus 9 is a negative 18, and negative 18 goes there. Uh-oh. If we translate this last row into an equation, it's 0x plus 0y equals negative 18. Well, but except 0 is not equal to negative 18, so this is an absurdity, so this had to be absurd in the first place. This initial system had no solutions. If eventually you get a 0, 0, non-zero, no solution. If you get a 0, 0, 0, then you won't have enough information to specify a complete answer. So it'll be underdetermined, whereas this is what's known as overdetermined. So this one has no solution. If it was all 0, 0, it would be insufficient information. Now we have a 3 by 3 system. And 3 by 3 systems are basically more than twice the work of a 2 by 2 system, because there's more than twice the numbers in it. 6 versus 12, well, yeah, twice the numbers in it. Whatever. So x plus y equals 6, that's 1, 1, 1, 6. X plus 2y plus z equals 8, 1, 2, 1, 8. And 1x plus 1y plus 2z equals 7, 1, 1, 2, 7. Okay, there's the augmented matrix. I'll use this one to clear away these ones here. I'll do that by subtracting row 1 from row 2 and subtracting row 1 from row 3. 1 minus 1 is 0, 2 minus 1 is 1, 1 minus 1 is 0, 8 minus 6 is 0, it's 2, 102. 1 minus 1 is 0, 1 minus 1 is 0, 2 minus 1 is 1, 7 minus 6 is 1, 0011. Well, what do you know? Look at this. We already have z equals 1. That's nice. But hold on. We have something convenient here. We can use this one here to eliminate that, and this one here to eliminate that. Now the zeros here won't interfere at all. So we'll take this row and subtract row 2 and row 3. 1 minus 0 is 1. 1 minus 1 minus 0 is 0. 1 minus 0 minus 1 is 0. 6 minus 2 minus 1 is 3. And lo and behold, we already have it all done. 1x equals 3. 1y is 2. 1z is 1. X is 3. Y is 2. Z is 1. And there's your solution. Here we have another system. 5x plus 3y is 4. 3y minus 4z is 4. X plus z is 1. Now each of these is only 2 of 3 variables. So this is going to be zeros in the augmented matrix. 5x plus 3y plus 0z is 4. 5, 3, 0, 4. 0x plus 3y minus 4z is 4. 0, 3, negative 4, 4. 1x plus 0y plus 1z is 1. 1, 0, 1, 1. Okay. I guess what I'll do is I'll use this entry here to clear away this 0 here, this 4 here. So add 4 of row 3 to row 3. Row 2. 0 plus 4 times 1 is 4, so it gets a 4 there. 3 plus 4 times 0 is 3, so put a 3 there. Negative 4 plus 4 times 1 is 0, so put a 0 there. 4 plus 4 times 1 is 8, so put an 8 there. Okay, so we've cleared things away. This is pretty coincidental. We have 5304, 4308. A simple subtraction will clear away this. So we'll take row 1 and subtract row 2 from it. 5 minus 4 is a 1 there. 3 minus 3 is 0, 0 there. 0 minus 0 is 0, 0 there. 4 minus 8 is negative 4, 0 there. Already we're seeing that x is negative 4. Great. I'll use this one here to clear away this 4 and this 1. We'll clear away this 4 by subtracting 4 of row 1 from row 2. Also clear away this one, subtracting row 1 from row 3. 4 minus 4 times 1 is 0. 0 goes there. 3 minus 4 times 0 is a 3. 3 goes there. 0 minus 4 times 0 is a 0, which goes there. 8 minus 4 times negative 4 is 8 plus 16, which is 24. Here, 1 minus 1 is 1 minus a 1 is a 0. 0 goes there. 0 minus 0 is 0. 0 goes there. 1 minus 0 is 1 goes there. 1 minus negative 4 is a 5, goes there. Okay, this is almost the diagonal. 1x is negative 4, 3y is 24, 1z is 5. For this row here, we'll divide throughout by 3 to rescale it. And so get 100 negative 4, 0108, 0015. So x is negative 4, y is 8, and z is 5. And that's the solution to this system. Okay.